This is the lesson video for chapter 7, part 2. In this section, we're going to join a table to itself using a self join. Okay, so we come to a self join, and we're going to go to SQL Developer, and we're going to join employees, and the first appearance of employees, we're going to give it an alias of E1. And employees, we're going to join it to itself, and we're going to give E2 alias for the second occurrence of employees. So let's go look at employees table. Refresh. I'll run the countries. We'll go to employees. So we come to employees table, and you see we have an employee ID, and over here at the end we have a manager ID. Alright, so for employee 101 Nina, we have manager ID of 100. So person employee ID 100 is Steven. So we have the manager information in the same table. Right? We just need to join it to itself to extract that information. Alright, so we're going to join employees to itself. Right? So we're going to get employee ID from the first occurrence of employee. We're going to get first name from the first occurrence of employee, last name, and manager ID from the same occurrence of employee. So now we're going to get from the second occurrence, we're going to get the first name. That will be the manager's first name. We give the appropriate alias, and then we get the manager's last name from the second occurrence. We give it the appropriate alias, manager's last name. We also use aliases for the first for all the columns of the join. Right? So here we're using join on, and we join manager ID to employee ID. Right? Manager ID from the first occurrence of employees, and employee ID from the second occurrence of employees. Alright, so we run it, and let me just sort it. Looks there. Okay, so we run it, just sorted it. So employee 101, the manager ID is 100, and that happens to be Steven. Right? So for every employee, we get their corresponding manager information. Alright, that's joining a table to itself using join on. Now we go to the third section, view data that does not meet a join condition using outer joins. Here we're going to cover inner versus outer joins, left outer join, right outer join, and full outer joins. Here we have inner versus outer join. And let's go to SQL Developer. So let's look at employees first. Employees, okay. And we're going to join to the department. So there's one employee that doesn't have a department ID, and that's Kimberly Grant, right? And it's employee 178. So if we do an inner join, because that employee doesn't have a department ID, and we're joining employees to departments table, this employee, because they don't have a department, they're not going to come up. And with the inner join, that's what's going to happen. So employee 178, so we look for employee 178, and employee 178 is not there. We jump from 177 to 179, right? And the reason the person didn't come out is because they didn't have a department tied to them. And an inner join, we simply use join on. The keywords join and on. And again, we're joining employees and departments, and this is an inner join because we don't get so people that don't have information in the departments table or don't have a department ID in this case are not going to show up in an inner join. Okay, and here we use an outer join. We use a left outer join, and it's simply the same thing, but we add the left outer join, and we're joining again employees and departments. And with left outer joins, those that don't have information on the join tables will come out. So employee Kimberly 178 is going to come out in the left outer join or outer join. So we run it and we go to 178, probably 178. This employee comes out even though they don't have a department ID. Okay, and that's with an outer join, right? The inner join does not do this. Let me just show you in the next slide. This is the inner join, this is the outer join, and this is the screenshots from the tables. With inner join, we don't get Kimberly, employee 178. With an outer join, we do get Kimberly and no information for the department because she doesn't have the department ID. Alright, so always be very careful if you want to get a listing of all employees, regardless whether they have a department. You use outer joins. I basically use outer joins 95% of the time, right? So you don't want to miss. In most cases, you don't want to miss records. You don't want to miss employees in lists or reports. Right. So this is the outer join. I use the example of left outer join. For left outer joins, it's the same thing. The same example that we saw earlier. Now I also wanted to show you another way of running left outer joins. And this is how I learned how to do left outer joins back in the day. I learned how to do left outer joins using the where clause. So again, you list all the columns that you want, and then you list the tables that you want, in this case employees and departments, and we give it the Proprius alias just to figure out what columns from where we want the columns. And then we use a where clause and we join department ID to department ID. The only thing that makes this a left outer join is this plus sign encapsulated in department ID on the right side of the equation, right? So this is a left outer join just because of this. If it wasn't this, if we get rid of this, it's just an inner join. And Kimberly employee 178 does not show. Does not come out. See, 178 does not come out. So we add that plus sign. And we run it. Now you get employee 178. Even though she doesn't have a department ID. Now we come to right outer joins. This is a similar. In this case, we're getting information from the departments and employees. In this case, departments comes first, then employees. So we have to do a right outer join, I think, because of the sequence of tables. So we want to get every employee regardless of whether they have a department, and we're putting a work condition, and we use the keyword right outer join, and we're joining them by department ID, and we use a work condition to just get people whose last name starts with a G. So we get Kimberly, her last name is Grant. Alright, and this is because of the order of where we get the tables. First we list department, then employees, so it's going backwards. If we did not get the right outer joint, we would get Grant or Kimberly. If we get it, we do it, we get Grant. And here we're just a smaller example, we're getting last name from employees and department name. Now we go to full outer joins, and full outer joins basically gets information from both tables. If they don't have any matching, if they don't have any Kimberly doesn't have a department, and these departments don't have employees, so it goes backwards both ways. Alright, it goes to the right and to the left. Again, this employee, Kimberly Grant, doesn't have a department, and these departments don't have any employees. And that's a full outer join. Now we come to the next section, generate a Cartesian product of two or more tables. A Cartesian product or a cross join is formed when every row from one table is joined to all rows in another. And we saw this earlier. Let me go to SQL Developer. So we go to the jobs table. We're going to do a cross join in jobs and history. So the jobs table has 19, and the job history has 10. And we do a cross join, and we get every single combination of both tables. So we get 190. So jobs had 19, and job history has 10. That's 10, so you multiply 10 times 19, you have 190. So you get every possible combination from both job history and jobs. That's when you use a cross join or Cartesian join. The next example is similar. We use a cross join, job history, and in this case we use a where clause. And we get the results. Smaller result, less results because we filter it by job ID. That's the end of the lesson video for chapter 7, part 2.